This module examines the special budget process called the capital budget for handling high cost and long life purchases or construction projects. The annual operating budget is the yearly plan for regular and recurring expenditures. It's a consumption-oriented budget because staff worker time and the supplies and services used during the year are consumed. A new year carries with it the obligation to fund it all again if the same staff and planned services continue. In contrast, a capital budget is an investment-oriented budget process. The focus here is on non-recurring outlays that provide benefits for several years. Capital budgets focus on individual capital projects which exceed a dollar hurdle amount, such as anything over $10,000. Each capital project produces a capital asset that has a useful life or lifespan of over 1 year. For example, a new lab testing machine may cost a lot of money, but last for many years. It costs so much money that there is no way for it to be paid for all at once out of yearly revenue sources. Either the money has to be saved up over many years, or a one-time infusion of money is required from a donor or government agency, or by borrowing the money with an agreement to repay the borrowed money over several years. Often, the organization can identify several capital assets that are needed, perhaps different large equipment items, a new building, new vehicles, or other high-cost items. Another way to think of a capital project is that it's a capital asset, with the monetary value of its remaining useful life placed on the balance sheet. When there are multiple capital assets needed, a capital improvements program offers a way to schedule out the purchases in priority order. We'll discuss that in a few minutes. So, what is the capital budgeting process? It can be a quick one or a more elaborate process. If your organization has few, if any, large purchases or construction needs, then there's no need to do a capital budget. But we'll walk through the entire process itself and take a look. First, it helps to have a clear rule on what is a capital project. For example, it might be stated this way. A capital project is one that has a useful life of 2 or more years and costs more than the average salary of our workers. This type of definition places the capital asset outside of what would normally be consumed or used completely in one budget year. And it sets a relatively high price tag as conveyed by how costly it is to add a new staff member in a tight budget environment. Second, there may be all types of capital assets that would be nice to have. Some projects are obvious due to things like ceiling leaks or broken machinery. Other capital projects are identified because buildings or equipment are nearing the end of their useful life. Then finally, new building codes may require upgrades in the facilities to accommodate certain medical services. Third, each proposed capital project should be evaluated separately as to its costs and benefits. Some examples include a piece of new lab testing equipment costing a huge amount of money may return annual dividends throughout its useful life by providing higher quality results. Or a new type of test that can earn fees paid by the client. Or finally, other benefits that can be realized over time that would outweigh the large upfront purchase cost of the capital project. Fourth, where will the money come from to buy or build the capital project? Will it require a new source of money, perhaps from a new donor or government agency? Is it possible to save money over several years to accumulate enough to buy it outright? Or will the organization have to borrow the money? There might be a way to put off, for some time, the need to buy a new piece of expensive equipment to replace the one that's being overused, and thus get closer to the end of its useful life. Maybe it's possible to ration its use to extend its useful life. If the useful life is defined by the number of tests run on the equipment, maybe there's a way to redesign the service so fewer tests are run on it for each client seen. This is an example of changing the rules. Although it's likely to be unrealistic to do in most labs, differential pricing is another way to manage demand by charging more for congested periods of use and less for less congested periods. The fifth step in the process arises when there's more than one capital project to consider. Which project comes first? What priorities do you use to rank proposed projects, each of which may offer a range of different impacts on services? One approach is to prioritize using an imposed rationality or technical basis. An example may be saving lives. It gives highest priority to the capital project that has the highest probability of saving lives, as opposed to only those nice-to-have things such as shiny cars, which might be ranked near the bottom of the priority list. Another priority basis might be funding, as in, can it get funding from a donor or government agency well ahead of other more desirable, even needed capital projects? Be careful when taking such money. For example, what if that new donor would buy a truck that is low on your list, but only if you offer a new service addressing a new target group? That might seem like an acceptable agreement, but what if you really need some life-saving equipment for an existing service that your target group expects you to provide? Once you take the truck money, you're now obligated to shift some funding to the new service while weakening the long-standing service function. In government, we often see that the politically accepted but low priority by technical standards capital project gets funding well ahead of the really needed project. Sixth, the governing or executive authority has to approve the purchase of the items in the capital budget. Implementation, the seventh step, entails the purchase or construction of each capital project. Of course, once it's obtained or built, you have to operate and maintain it. This is a burden that will fall on future annual operating budgets. Now we can look at the elements of a capital project request. Here are the common characteristics to include in such a request. The request should include all costs related to its purchase or construction and any justification for the project. It should also consider the future impact on the operating budget, such as the personnel to maintain or run the equipment, annual maintenance expenses, supplies to run the equipment, variable supplies tied to the number of users, and the annual payment to pay back over time any borrowed money. Here's an example of a capital project request. Purchasing a new lab testing machine. The amounts aren't shown here, but of course any budget request would have to offer precise cost data. There are direct costs which wouldn't be needed except for the use of this new machine. Direct costs might include the new staff or additional hours for existing staff to work the machine, the supplies to calibrate and run the machine, and the annual maintenance costs. There are also indirect costs, which might include the time of an existing manager to supervise the staff dedicated to operating this new machine. Fixed costs would be the use of existing unused room space. And finally, variable costs would be for the supplies needed for each patient tested. Therefore, that cost would go up or down as more or less patients are tested. In conclusion, budgeting for high cost and long life capital assets deserves intensive inquiry, questioning, and planning. Mistakes can last for multiple years, but good capital investment decisions provide dividends for many years.